Hey guys, welcome to part 2 for the what you need to know for the graphs internal. For this video, we're going to be walking through the second part of our exponential, and we're going to be moving on to cubic, parabola, and square root, which should be the more straightforward of the bunch. Okay. Alright, so for our exponential, okay, we're going to be using as you can see, the asymptote seems to be going down to 0. Okay, the asymptote is traveling towards 0, so we're going to say I will assume the asymptote is y equals to 0. So therefore we can say y equals to k times a to the power of x. Now we're going to look at the intercept, the y-intercept, okay? So y-intercept is at 0, 2, okay? So because the y-intercept is at 0, 2, okay, this means that our k value is 2 because it intercepts at y equals to 2. So therefore, we'll say y equals to 2 times a to the power of x. And we're going to substitute one more point to find a, okay? So we're going to substitute this point here, which is 2, 3. We're going to say 3 equals to 2 times a to the power of 2. Move the 2 to the other side, becomes divide. So 1.5 equals to a to the power of 2. A equals to square root of 1.5. So pretty straightforward. Our equation would just be y equals to k, which is 2 times square root of 1.5 to the power of x. Yeah, pretty straightforward for this question. Okay. I'll be moving on to our cubic. We'll do square root first. We'll be moving on to our square root graph next, which is extra. Not this is probably one of the easiest graphs in the internal. Okay, so our square root graph looks something like this. Okay, that works. Okay, so our square root graph would look starts at 0, 0. So if we say, no, we'll say starts from here. So we say our square root graph starts from here. So y equals to k times square root of x. Okay, so that's our standard equation. Okay, so as you can see here, this graph has been shifted. As you can see, it's been shifted 1 unit to the right. Okay, so because when x equals to 0, y should equal to 0. For this equation, if x equals to 0, square root of 0 is 0. Anything times 0 is 0. So if x equals to 0, y must also be 0. But here, x equals to 1 and y equals to 0. So square root of 1 is 1. So that means our graph must have been shifted 1 unit to the right. Okay, so 1 minus 1 is 0. Okay, so and our k value can't be 0. Okay, so we say y equals to k times square root of x minus 1. Okay, and we'll substitute one random point to find our k value. Okay, we'll say good point. We'll say this point here, that 3, 3. So we substitute 3 equals to k times square root of 3 minus 1. 3 equals to k times square root of 2. So if we say k must be equal to 3 divided by square root of 2. So therefore our equation would be y equals to 3 divided by square root of 2 times x to the power of -1. Not to x to the power of x minus 1. Square root of x minus 1. If we shifted the square root up or down, okay, that would be plus c, okay, if we shifted it up or down. But as you can see, we didn't shift it up or down, okay. So for example, our square root graph started from somewhere here. Then as you can see, it would have been shifted up or down, okay. But for this graph, it starts at y equals to 0, so it hasn't been shifted up or down. Alright, so that's basically it for the square root graph. Pretty straightforward, okay. We'll be looking at a parabola now. Parabola is also pretty straightforward. So we have two basic ways of doing our parabola. So that's y equals to a x minus b x minus c. B and c are our x-intercepts, okay? or we can say y equals to a, x minus b whole squared plus c. B and C are coordinates for our vertex of our parabola, which is both pretty straightforward. We should have done this in level 1. Okay, so for example, I'll just make 2 quick examples. Okay, so we'll say this parabola, for example. Okay, that's such a bad parabola. Wow. That's also a bad parabola. Shocking. Yeah. Okay, so say for example this parabola here. Okay, we'll use the x-intercept equation. We'll say y equals to a 1, 2, 3, 4 x minus 4 x minus 8. We'll say that this point here, that's 7, negative 3. So say negative 3 equals to a 7 minus 4, 7 minus 8. Negative 3 is a 3, negative 1. Negative 3 equals to a what am I doing? Equals to negative 3a. Oh wow, a equals to 1. So there's no a value. What a coincidence. Y equals to so basically you say y equals to x minus 4, x minus 8. All pretty straightforward here. Yep. That's basically our x-intercept format. Okay, our vertex equation, that's also pretty straightforward. We'll say we'll just give a random parabola. We'll say okay, it's pretty badly drawn. Okay, but we can use our vertex equation here. Okay, we'll say that this point is 1, 2, 3, 4, 5, 6, -6. -6, -8. Okay, that's our point. Okay, so then we have our equation. So y equals to a, x double negative makes a positive, so x plus 6 has been shifted down by 8, so that's our coordinates of minus 8. We'll substitute one more point to find out a value. Okay, we'll say that this we'll just say this point 1, 2, 3, 4, 5, 6, 7, 8. We'll say this is -8, -5. Okay, so we say -5 equals to a, -8 plus 6, or whole square for the square, so -8. -5 equals to -8 plus 6 is -2. -2 squared is 4, so 4a minus 8. Move the 8 to the other side, so 3 equals to 4a. A therefore equals to 0.75. So therefore our equation is y equals to 0.75 x plus 6 whole squared minus 8. Okay, so again, this is pretty straightforward. Okay, shouldn't have to spend too much time here, so we just move on to our cubic. Okay, pretty similar to a parabola, except there's one more x-intercept basically. Alright, so basically for our cubic, okay, so for example we have our cubic here, three intercepts. Okay, so dang it, it's pretty bad. Okay, we'll say it goes through this point. Oh gosh, sorry guys. Okay, we'll try this again. Okay, that's pretty badly drawn, but okay, so for example we have our cubic here, so our standard equation for our cubic is y equals to a, x minus b, x minus c, x minus d. So b, c, d are our x-intercepts. Okay, so x-intercepts are at -5. Okay, so we have our x-intercepts at -5, 1, and 4. So we have y equals to a, x plus 5, x minus 1, and x. We also have x minus 4. We'll substitute one random point to find for our a value. Okay, so we'll say this point here. We'll say this point. So that's 5, 1. Okay, so we say 1 equals to a, 5 plus 5, 5 minus 1, no, 5 minus 1, 5 minus 4. 1 equals to a, 10, 4, and 1. Okay, so 1 equals to 40a. 1 equals to 40a, so therefore a equals to 1 over 40. Therefore our equation is y equals to 1 over 40, x plus 5, x minus 1, x minus 4. Okay, so another possible way they give you equations for your cubic is say they don't give you the ones cutting the x-axis. Okay, so for example they'll say a nasty cubic, for example. They're gonna be it's gonna be look something like okay, it's gonna look probably look something like this. Okay, so for this types of cubics, okay, we're gonna be shifting the graph up. Okay, so for example, this point here, we're gonna shift it up by 1, 2, 3 units. Okay, so then our equation becomes y equals to a to the power of x minus b, x minus c, x minus d. Okay, we shifted it up by 3 units, so at the end we'll add plus 3. And then after we move it up, okay, so this point will be here, and this point here will be here. Okay, so then we'll have okay, so this point here is a turning point. Okay, which means y equals to a that's x plus 8 whole squared, x plus 4 plus 3. Okay, we'll substitute one random point to find for our a value. Okay, so we'll say -5, so this is this point here, -5, -5, okay, so -5 equals to a, -5 plus 8 whole squared, -5 plus 4 plus 3. So -5 equals to, so -5 plus 8 is 3, 3 squared is 9, 9 times -1 is -9a plus 3. So plus 3 to the other side, okay, becomes -3. So -8 equals to -9a. A therefore equals to positive 8 over 9. So then we'll say our final equation is y equals to 8 over 9, x plus 8 whole squared, x plus 4, x plus 3. Okay, so that's basically would be our final equation here. Okay, not too much, not too stressful in my opinion, but hopefully you have a better understanding of how to do the cubics when you're faced with the question. Okay, alright, so thanks for watching this video. Okay, if you liked the video, please leave it a like. Hopefully this video isn't too late for you guys, but yeah, thank you for watching the video. See you in the next video. Thank you. Bye.